In testbed 18, interactive instruments investigated how to share aeronautical data via APIs implementing OGC API standards. We looked at two different types of APIs. The first type focuses on providing direct access to the data, the second on filtering the data so that users of the API can fetch only the data that they need for their data analysis or processes. Let's start with the first type, the data API. The data APIs are facades to existing SWIM data, which were originally set up in OGC testbed 17 and which have been updated in testbed 18. This component provides three APIs to access SWIM data: for NOTAMs or notices to airmen, for airports, and for airspaces. The APIs have been configured as minimal OGC Web APIs for sharing feature data. That is, only the first part of the OGC API feature standard is supported, the core. Only simple filtering of the data is supported. In addition, vector tiles are also provided to support using the data in maps. This demonstration is about a server component that publishes APIs. APIs are typically accessed by applications like the business or developer client. However, all APIs of this component also support HTML representations of the resources so that a web browser can be used to navigate and explore the API. This allows anyone to get an idea of the available data and capabilities, even without a specialized application. We will use a web browser to explore the APIs. Let's first have a quick look at the facades. The airports facade provides access to information about the infrastructure of airports in the United States according to the Aeronautical Information Exchange Model AIXM. The data includes information about buildings, aprons, taxiways, runways, etc. We can browse through the data. The data can be accessed as GeoJSON, JSON-FG, or flat GeoPath. To visualize the airports in a client, the data is also available as vector tiles. Here we see LAX. We can switch layers on and off. Since the data is provided as vector tiles, the features and their attributes can be accessed in the map too. Here we can see the other airports and zoom in again to see more details. A second facade provides access to NOTAMs with a location reference. This dataset is updated live from the SWIM data feed. Currently, there are more than 6 million NOTAMs. Here we can see recent NOTAMs. Now let's switch to the APIs with filtering support. A second set of APIs for the same datasets has been set up with advanced querying capabilities. We will demonstrate the different capabilities when we look at these APIs. Again, we start with the airports. This API does not provide access to vector tiles, but it provides access to stored queries that have been pre-configured to simplify submitting queries. This HTML page provides a simple interactive HTML view of the stored queries or filtering rules. We can see three stored queries. The HTML view allows to select values for any of the parameters and to execute the queries. The first query is very simple and only allows to fetch apron, runway, and taxiway elements made from concrete for the three major New York City airports. I can only select the format of the response. Let's select HTML so we can see the result directly in the browser. The values are returned in pages with 100 objects per page, and I can browse through the results. And the second query adds parameters to select one or more airports and the type of the element. I can pick values from the list of values. For example, parking positions at Newark. How is such a filtering rule specified? It is a JSON document that specifies the query. Here we see the query that we just executed. It has an identifier, a title, and a description that explains the query. We can query one or more collections or feature types. Here we query three feature types: apron, taxi, and runway elements. Results are returned sorted by the airport attribute. Next, we have a global filter that is applied for all feature types since they share the same attributes. Filter expressions are expressed using the JSON variant of the upcoming Common Query Language Standard, CQL2 for short. The first selects the type of element. The valid values are specified. There is also a default value in case I do not provide a value when submitting the query. The second predicate selects the airports and also has the valid values and a default. The properties element reduces the attributes that are returned with the results to the listed properties. And finally, we limit the results to 100 objects per page. The final query provides access to all objects of an airport. Here we see Pittsburgh Airport. For the notices to airmen, we have defined a sample stored query to retrieve NOTAMs in a time interval by keywords and in a corridor between Dallas Airport and JFK. So far, we have accessed the data as HTML to view it in a browser. We can also fetch the data in a feature format and then use the selected data in a GIS client. Here we select the apron, taxi, and runway elements of JFK as a flat GeoBuff file and open it in QGIS. Flat GeoBuff is a proposed new OGC community standard. Thank you very much for watching this presentation, how interactive instruments shared aeronautical data via OGC Web APIs in OGC Testbed 18. The work on advanced filtering for SWIM feature data leveraged several OGC API standards or candidate standards. Implementation feedback, in particular on the Common Query Language CQL2, has been provided to the Features API Standards Working Group and helped to improve the specification. In addition, the Filtering Service and Rule Set Engineering Report includes a specification for additional capabilities tested during Testbed 18. Queries can return features from multiple feature types, parameterize stored queries, and managing stored queries via the API. The OGC Features API Standards Working Group plans to use the Testbed 18 results as input to a new part of OGC API features.